Welcome to Ask and Learn.
Sorry, I'm feeling a little sick. All right, guys, we're doing problem 54 in chapter 5 of Chemistry Essential Science. So consider the data about gold metal in exercise 5.26. So we have a 100-gram piece of gold that's heated from 25 degrees to 50 degrees and absorbs 322 joules of heat at a constant volume. So based on data capture the specific heat of AU. So we're going to do Q is equal to MC delta T, and we're going to solve for C here. So let's solve ACAU is equal to Q over M delta T, which is equal to 322 divided by 100 times 25 so CAU is equal to 0.13 joules per gram times degrees Celsius. That's the heat capacity of our gold bar. Now, for part B, they want us to think about this. Suppose that the same amount of heat is added to two 10-gram blocks of metal, both initially at the same temperature. One is gold and one is metal. Which block will have the greatest rise in temperature after the addition of heat? So if these, are going to have, you're adding the same amount of heat to each one, and you're going to add these, and you're adding the same amount of heat to each one. They're at the same mass. Then the one that's going to have a greater increase in temperature is going to be the one is going to be based on their difference in heat capacity. And the heat capacity of iron here, since gold has a lower heat capacity than iron, it takes less energy to heat the block up to a specific temperature. So that means that your gold is going to end up at a higher temperature than your iron because it has the lower specific heat value. So in this case, gold is going to be your answer. Now they want us to know what has the molar capacity of heat. So it basically is this. They want us to convert joules per gram degrees Celsius to joules per mole times degrees Celsius. So you can write it like this: joules per gram degrees Celsius times 197 grams per 1 mole. That's going to equal 0.13 times 197, 25.61 joules per mole times degrees Celsius. That's going to be the molar heat capacity of our gold.